Welcome to The Explainer. Let's jump right into a fascinating, almost alchemical mystery of human metabolism. We talk about calories and nutrients all the time, but have you ever actually stopped to think about the sheer physics of eating? Like, what actually happens to the physical mass of the food we eat? Picture a heavy, solid 6-ounce cooked lean steak sitting right there on a plate. That is exactly 170 grams of physical matter. You can literally feel its weight in your hand. You can see the volume it takes up. It's a tangible, solid object. Which leads us to a pretty fundamental question. Where does this weight actually go once you swallow it? We've all heard the old saying, you are what you eat, but we know intuitively that this 170 grams doesn't just magically pop out the other end as a 170-gram block of solid waste. And it definitely doesn't immediately bolt onto your biceps as a permanent solid mass of muscle. The math just doesn't add up the way we usually think about it. We've got a missing mass problem. Section 1. Breaking down the steak. To solve this case of the disappearing mass, we first need to figure out what that 170 grams is actually made of. And what's really wild here is that the vast majority of that heavy, solid steak is actually just water. Out of our 170-gram total, approximately 110 grams, nearly 4 ounces of it, is water that gets absorbed directly into your body's overall water supply. Then we have about 45 grams of protein, a mere 8 grams of fat, essentially 0 carbs, since meat doesn't really supply sugar or starch, and about 7 grams of minerals and other compounds. This breakdown is absolutely vital. It completely resets our expectations and sets the stage for some serious metabolic transformation, because what happens after absorption is where the real physiological magic lies. Section 2. The muscle and fat myth. Let's tackle our first set of suspects. There's this huge misconception out there that dietary protein directly and permanently becomes muscle and that eating dietary fat just permanently stays on your body as body fat. Well, let's trace that 45 grams of protein. It gets completely dismantled in your digestive tract into small peptides and amino acids, and then enters what we call the amino acid pool. Think of this as a grand, continuously flowing biological basin circulating within your body. And here is a critical, kind of counterintuitive fact. There is essentially no dedicated protein storage tank in the human body. Your body can't just squirrel away extra protein for a rainy day. Those amino acids are consistently being drawn upon to create whatever your body needs right at that exact moment. It might become muscle proteins, sure, but it also might become enzymes, hormones, antibodies, intestinal tissue, or even your skin. And this is exactly why we can't just trace a straight line from a bite of steak to a bulging bicep. It's a huge oversimplification, a total myth, really, to claim that if you eat 45 grams of protein, you can perfectly say, well, 30 grams became muscle and 15 grams became urine. In reality, the fate of that protein is dictated by a massive web of factors. We're talking your overall size, your energy balance for the day, your recent meals, your exercise routine, and your immediate cellular protein requirements. If your amino acids exceed your body's immediate needs, the nitrogen gets removed and the remaining carbon skeleton, it just gets oxidized for energy. The exact same logic applies to the fat content. The steak contains about 8 grams of fat, which gives it a theoretical energy content of roughly 72 calories. But eating those 8 grams does not equal an 8-gram permanent increase in your body fat. Even if you absorb every bit of it, fat is continuously entering and leaving your fat cells. Some of those fatty acids are burned for energy right away, while others might be used to build cell membranes. Your metabolism is a highly dynamic exchange system, not a static storage unit. Section 3. The truth about waste. So, if the heavy physical mass of the steak isn't permanently sticking around inside you as layers of muscle or fat, it must be coming out the other end, right? Well, we established earlier that roughly 110 grams of the steak is just water. But it's a massive mistake to calculate this as a simple steak in equals urine out equation. That 110 grams simply joins your body's massive common water pool. Your kidneys are the ultimate master regulators here. They monitor the combined water coming in from the steak, your drinks, other foods, and even the water produced internally by your metabolism. They then decide what to do with it. That water is eventually lost, sure, but it's distributed across your urine, the moisture in your breathing, your perspiration, and your stool. Heck, if you're slightly dehydrated, your body might just hold on to that steak water entirely. So 110 milliliters of steak water absolutely does not mean an immediate, equal volume of additional urine. Now, what about the waste from the protein? When amino acids from our 45 grams of protein are broken down and not used to build tissue, their nitrogen is removed. Since protein is about 16% nitrogen, this process creates roughly 7 grams of nitrogen waste.
This eventually turns into roughly 15 grams of a compound called urea, which your kidneys eliminate in your urine. But remember, it takes hundreds of grams of water to carry that urea out of your body, and that huge volume of water cannot be meaningfully attributed solely to this one steak.
And here is the slightly humorous, myth-busting truth about solid waste. When you look at the composition of a typical bowel movement, it's mostly water, bacteria, shed intestinal cells, mucus, digestive secretions, and fiber from other foods. Lean steak, however, is highly digestible and contains virtually zero fiber. Most of its protein and fat is just fully absorbed. This means out of that original 170-gram hunk of meat, perhaps only a few grams or even less of genuinely undigested food material actually ends up in your stool. In a healthy person, your body is incredibly efficient. So it's not muscle, it's not fat, it's not a massive surge of urine, and it's certainly not stool.
Section 4. Breathing out your food.
Okay, we've thoroughly checked all the usual suspects: muscle, fat, urine, and stool. And yet, the vast majority of our original 170 grams of physical mass is still completely unaccounted for. Which brings us to the ultimate twist. Let's see how this builds, because this is where the science gets truly fascinating. After digestion and absorption, when your body decides to use those amino acids and fatty acids for energy, their carbon atoms undergo an incredible transformation. Simply put, food plus oxygen converts into carbon dioxide, water, and energy. A substantial portion of the solid mass you eat is quite literally burned for energy, turning its solid carbon atoms into a gas. That's right, over time, you breathe your food out into the air. The steak leaves your body through your lungs. I really want you to think about this next point from the source material, because it is frankly mind-blowing. The law of conservation of mass dictates that matter cannot be created or destroyed. But because your body is continuously pulling in heavy oxygen molecules from the room every time you inhale and attaching those to the carbon from the steak during metabolism, the waste products, meaning the CO2 and metabolic water, actually weigh more than the 170-gram steak you started with. Mass is perfectly conserved. You just added to it with the air you breathed. We finally solved the mystery of the disappearing mass. We've tracked the water pool, broken the protein myths, and discovered the incredible reality that we literally exhale our meals. But it does leave us with one final fascinating question. If we really wanted to trace every single gram down to the precise decimal point for a specific individual, say a 190-pound man eating an 1,800-calorie diet, what would that ultimate alchemical tracking model even look like?